Take a moment and look around. What objects do you see? Some of them are polygon, like a bridge, or if you have bricks, that's also a polygon, or maybe a Christmas ornament. Some of them are not polygons. They're curves, like coffee bean, flowers, or a cello. Now, when doing math, we don't usually talk about pictures. Rather, we talk about figures. So it'd be good to look at some examples of polygons and non-polygons in a figurative way. So you have your nice triangle and a rectangle. We can also think about hexagons, but something like an arrow is even a polygon. Whereas if you have a partial circle, or some curve, or a cube, or an figure like this would not count as polygons. So why is that? Think for a second and come up with your own argument. So what makes it a polygon? It needs to be closed, so a curve like this would not count toward a polygon. It needs to have an inside and outside. It needs to have straight sides, so a partial circle would not be a polygon. It also needs to be two-dimensional, so cube is not a polygon. And it needs to have no cross lines, so this figure is not a polygon. So what are some examples of polygons? We usually classify them by the number of sides. So we have triangles and quadrilaterals, the four-sided ones, your favorite rectangle, your parallelogram, and a trapezoid. Now we can also talk about some polygons with large number of sides. So we can talk about Decagon, so that's sometimes called tengon. Would be a 10-sided object like this, but it doesn't necessarily have to be in this shape, as you can draw a star, and you can easily see that this star has 10 sides. So this would also be a decagon as well. We can do something similar for the decagon or 12gon. You can draw a regular dodecagon, which would look very much like a circle, but you can also draw a star. This has 12-sided, or a cross, which also have 12 sides. So your polygon doesn't really have to be symmetric. And what we're going to talk about now is how we can classify some of the polygons using their difference in the shape. First, we're going to talk about regular polygons. So what are regular polygons? Regular polygons are equilateral and equiangular, which simply means that they have same side length and same angles. So examples of regular polygons would be your regular triangle, equilateral triangle, a square, or maybe a regular hexagon. Whereas non-regular or irregular would be a star. That would be equilateral because, as you can see, they have all the same side length, but not equiangular. And your rectangle would be an equiangular example, but this is not equilateral, as you can see. Another way of classifying a polygon would be looking at whether it's convex or not. So a polygon is convex if, for all points A and B in the polygon, the segment AB is contained entirely within the polygon. Now this is somewhat hard to picture, so let's have a convex polygon and something that is not convex called concave. So let's say I have picked point A right here and B right there and try to draw a segment AB. As you can see, this segment crosses the border, so that this L shape would not be convex just because of that. Whereas with a triangle on your left, no matter what kind of segment you draw, it is always contained in the polygon. That's why your triangle is convex, whereas this L shape is not. Now here's a different way of seeing convexity. So let's start with this L shape. We know this is not convex. If we connect one of the vertex with the other one, you can draw this kind of dotted line. And you can see one of the sides actually go in, and that side needs to leave to come back to the exterior. So this is sometimes called convex hull. And it's not convex because this dotted line is not part of the edge that you want to have. So simply because of that, simply because one of them coming in and out, the interior angle needs to be more than 180 degrees. So in this particular L-shaped example, you can see the interior angle is measured at 270 degrees. Because you have to make that particular turn of leaving the area and going outward. So convexity can be also said as some internal angles having more than 180 degrees. Now this has crucial consequences. One of them is, one, regular polygons are never concave, they're always convex. Why is that? Well, you cannot have all angles over 180 degrees. It also tells us that all triangles are convex, and it's simply because the sum of angles must be 180 degrees. You can draw as many triangles you want and convince yourself that that must be the case. So here's a summary of what we covered today. A polygon is a two-dimensional figure that is made out of straight edges, which does not cross itself. A polygon can be either convex or concave. Examples of concave polygons include star-shaped polygons or L-shaped. A convex polygon can be regular or irregular. A regular polygon is made out of edges with the same side length and also with the same angles. Some examples of regular polygons are equilateral triangles, a square, and a regular pentagon, whereas your right triangle would be irregular convex polygon. Thank you for watching today, and we'll talk about more triangles next time. See you!